The association of mankind with the ocean dates back to the mythical past. Human sphere of action and its interaction with the ocean for effective exploration and sustainable utilization has resulted in the emergence of multidisciplinary areas of ocean technology. Recognizing the importance of these emerging areas, National Institute of Ocean Technology, NIOT, an autonomous institute under the Ministry of Earth Sciences, Government of India, was conceived and started as the technical arm of the erstwhile Department of Ocean Development in November 1993. Picturesque campus of NIOT at Pallikaranai, Chennai, accommodates different laboratories, administrative offices and other facilities. The major technology development programs undertaken by various research groups of NIOT: Research and Development Programs, Freshwater and Energy from Oceans, Deep Sea Technology and Ocean Mining, Coastal and Environmental Engineering, Marine Sensors and Systems, Ocean Electronics, Ocean Acoustics, Submersibles and Gas Hydrates, Marine Biotechnology, Offshore Structures. Operational Programs: Ocean Observation Systems and Tsunami Early Warning Systems, Vessel Management Cell. Rapid urbanization and population explosion and over-exploitation of groundwater resources are all increasing water demand. The mismatch between increasing water demand and decline in water availability due to over-exploitation and climate change is the most critical resource issue for policymakers. Desalination, which is the conversion of seawater to potable water through various physical and chemical methods, has emerged as a potential solution to India's and the world's looming water crisis. Conventional desalination process, reverse osmosis, is the most commonly used membrane process in the industry. High power consumption and the disposal of the concentrated brine are two of the major drawbacks of the process, and LTTD process is less power intensive, environmentally friendly, with advantage of minimum maintenance. Low temperature thermal desalination, LTTD, is one process that uses the availability of a temperature gradient between two water bodies or flows to evaporate the warmer water at low pressures and condense the resultant vapor with the colder water to obtain fresh water. The main components of the LTTD plant are the evaporation chamber, the condenser, pumps and pipelines to draw warm and cold water, and a vacuum pump to maintain the plant at subatmospheric pressures. National Institute of Ocean Technology, NIOT, has demonstrated LTTD technology using difference in ocean temperatures and established plants of various capacities. Two of such plants were successfully established in Minicoy, southernmost island, and Kavaratti, the capital of Union Territory of Lakshadweep. The advantage of the technology is that it can be implemented even with a low temperature gradient of about 8 to 10 degrees centigrade between the two water bodies. The Minicoy desalination plant with a freshwater capacity of 1 lakh litres per day was inaugurated by the Honourable Minister for Earth Sciences and Science and Technology on 22nd April 2011. Both the plants were running continuously ever since, fulfilling the needs of the 20,000-strong local community in the islands. Subsequent to the commencement of the plant for water supply for drinking water needs, there have been significant drop in the incidence of waterborne diseases in the islands. The freshwater production at Agathi commenced on 26th July 2011. The performance of the plant has been quite encouraging. The seabed bathymetry near the Agathi island was such that 400-meter water depth was available at about 850 meters from the shore. Temperature gradient of 18 degrees centigrade was utilized. Steel pipe of 500 mm diameter and 100 meters long is connected to the sump in the region where high wave activity and hard corals are found. High-density polyethylene HDPE pipes of 630 mm diameter and 750 meters long take over from the steel pipe to draw cold water from a depth of 400 meters. The seawater pumps inside the partitioned sump supply warm and cold water to the plant on the land. The salinity of the fresh water produced was reduced from 35,000 ppm of the seawater to 200 ppm, whereas the permissible limit for drinking water is 2,000 ppm. The deep sea cold water at a temperature of 12 degrees centigrade obtained from a depth of 400 meters is brought to intake sump located at water depth of 5 meters. The surface warm water at a temperature of 28 degrees centigrade is directly taken into sump. Pumps located in the sump transport both warm and cold water through the pipelines. A bridge is constructed to support the pipelines and also to connect the shore to the sump and plant. In the plant, the warm water is evaporated in flash chamber at a vacuum of 27 millibar absolute and condensed using the cold water. The main components of island-based LTTD plant are marine structure, deep sea cold water pipe and plant. Islands are generally made of coral with a lagoon on the western side and proximity of deep water on eastern side. The plant is located on the eastern side of the island. The design and construction of marine structure is a challenging task due to the prevalent ocean wave and current climate near these islands and subsequent lack of any heavy lifting or moving equipment or facilities for heavy work. The technical challenges in design and construction of structure are construction of concrete sump weighing 300 metric tons cast in lagoon and its movement to the site in floating condition through a distance of 10 kilometers, traversing the shallow channel in the lagoon. The sump was designed to take care of high waves of about 5 to 6 meters during the monsoon. Construction of the connecting bridge that crosses the intertidal region, the breaker, and extends up to a depth of 5 meters. The design and casting of the bridge piers and the deck to take care of the construction in high wave activity region is a particularly challenging task. High risks were involved in the construction of the bridge deck near the sump. Hence, plate girder bridge with concrete coating was launched from Pier 12 to Pier 15. The Institute has specialized in the design and construction of deep-sea submarine pipelines from water depth of 400 meters to 5 meters in environment of high ocean currents and waves. Deep-sea cold water pipes were designed and deployed in 3 islands of Lakshadweep. The 850-meter-long HDPE pipe is floated in the shallow waters of the island lagoon situated on the western side using buoyancy pontoons and transported to the plant site on the eastern side of the island. Agathi plant is unique in its design and construction. The bathymetry of Agathi is different from other islands where cold water pipe experience high wave and current loads. The pipe is anchored with solid concrete blocks in the shallow water region. The seaside of the pipe is weighed down and lowered to about 400 meters water depth. The cold and warm water is pumped to plant using submersible pumps designed and optimized for water level variations of ocean tides. The plant building at Agathi Island is located about 100 meters offshore in order to minimize the power consumption. All the process components required for generation of fresh water were designed and executed by the Institute. All the process equipment such as flash chamber, condenser and vacuum system were transported by sea from mainland and erected with the help of locally available infrastructure. The plant is fully automated and equipped with necessary instruments for continuous monitoring and minimal intervention. NIOT achievements in LTTD technology. Commissioned plants. 2011 land-based 100 meter cube per day plant in Agathi. 2011 land-based 100 meter cube per day plant in Minicoy. 2009 condenser reject-based 250 meter cube per day plant at NCTPS, Chennai. 2007, barge-mounted 1000 meter cube per day plant off Chennai coast. 2005, land-based 100 meter cube per day plant in Kavaratti. Not resting on past laurels, NIOT is implementing the LTTD plant in another 6 islands of the Union Territory of Lakshadweep, which includes Androth, Amini, Chitlat, Kadmat, Kalpeni and Kiltan Islands. Though the main objective of this program is to provide potable water to all inhabited islands through LTTD technology, the added benefit is capacity building in islands. It is heartening to see that sons and daughters of the islands actively participated in execution of marine structures, erection of heavy equipment, operation of plant and its maintenance successfully. NIOT strives to fulfill the nation's needs by means of ocean technology for fresh water, food, weather forecast, environmental monitoring and protection, sustainable harvesting of living and non-living ocean resources.